Welcome to the training video on points. So, looking at the Points tab, this is the part of the software that allows you to edit the names of the device, set the function of the device, set detectors to be a supervisory signal, set whether the smoke detectors will use alarm verification, and whether low temp trouble signals will be used on the heat detectors. It also gives you the options of setting the end-of-line resistor values and to disable the LED blink. If you run a learn via the control panel, the points you have addressed and installed in the field will be visible here in the points list. For example, notice that there have been smoke detectors, heat detectors, and several contact input pull stations added to my points list. The particular panel I am working on is an IPA 4000. You will notice at the top of the list is I have the built-in power supply, which includes the NAC 1 through 6 and I/O circuits 1 through 4. The built-in power supply circuits will always be defaulted to a conventional NAC general purpose on all IPA series control panels. If you plan to write the program from scratch, meaning you did not upload the configuration file from the control panel, and all of the SLC points will be defaulted to unused as you see here. If a learn is conducted at the control panel, then these functions along with the device type will be pre-selected. For instance, for the smoke detectors, you will not want to change them from a type smoke detector. If these were to be changed from a smoke to say a heat detector, and this program was downloaded to the control panel, a trouble of device mismatch type would appear. By clicking on the type down arrow, it will list all of the addressable detectors and modules available for the IPA control panels. If writing the program from scratch, you may choose Pad 100 PD for the photo detector, and now a function will have to be associated with that. The Pad 100 PD or photo detector is defaulted as a sensor only, but it can be changed by clicking the down arrow, which will show all available functions available for that photo detector. In this case of the smoke detector, you can choose sensor only, sensor with sounder base, or sensor with relay base. Also, once a device type is chosen, subpoints may appear. For instance, by selecting a Pad 100 TRTI, which is the twin relay twin input module, you will notice that 4 subpoints appear. They are 12.1 through 12.4. Again, 2 of the subpoints are the relays, and 2 of the subpoints are the input contacts. Once the device type selection is made, the function of those types can be again chosen by selecting the down arrow next to that certain device type, and then you can choose the function for that device type or that particular point. For some devices, such as the relays and the detectors, the functions may not need to be changed. However, any device that is labeled as a contact input pull station will most likely need its function changed. All MEMS, SIMs, and DIMMs default as a function type contact input pull station. These may be pull stations in the field, but chances are these may be input monitoring points such as water flow, a tamper, or alert signals. For example, points 7 and 8 are DIMM modules, and point 7 needs to be set up to monitor a water flow device and a tampered device. By clicking the down arrow, you can set 7.1 to monitor that water flow device, and you can set 7.2 to monitor that contact input tamper. So now you have one device that's only taken one address on the SLC loop. The last few points have been learned into the system as addressable relay general purpose. These are the Pad 100 relay modules, or RM, and these will need to remain the same, otherwise a trouble of device mismatch type would appear on the control panel. The NAC and I/O circuits can also be changed by clicking on the down arrow. You will most likely want to change these. A NAC circuit can be any of the following in the drop-down list. Each one of these circuits are individually configured, meaning that NAC 1 could be a Gentex sync, NAC 2 could be a system sensor sync, and NAC 3 could be set up as a conventional NAC aux constant. If I wanted to select multiple points and change their function at one time, I could left-click on the first point I choose to change, hold the Shift key, and click on the last point that I would like to change. And then just right-click over the highlighted points This will open up the same functions as before, allowing you to quickly edit multiple devices. So if I wanted to change these to a NAC Gentex Sync, I could do that now. You can also select multiple points by left-clicking on the first point you would like to change, holding down the Control key, and clicking on the next or the last point that you would like to change. Then just right-click as you've done before to open up the various functions available for those particular points. So remember, by clicking on the down arrow for an I/O circuit, these can be anywhere from a conventional NAC to any of the contact input circuits. So again, click on the down arrow to choose the specific device type or function for that particular point. Anywhere a column called name throughout the programming software allows you to customize that specific point or device name. This is limited to 16 characters. Be aware that with these 16 characters that you do not need to include any information that is listed in the function of that specific point. For instance, point 1 could be named floor 2, room 129. So by double clicking in that column, again, I'll name this floor 2, room 129. And do not need to include the fact that this is a smoke detector. In the event of an alarm, the control panel will display the address of the device, which is point 1. It will display the custom name, which is floor 2, room 129. And it will also display the function of the device. In this case, it is a smoke detector, a PAD 100 PD. And it will display the date and time that that device became active in an alarm state. Another example is for two devices that are located in the same room. For instance, if there is a riser room or pump room, you can name both your water flow device and tamper as pump room 428. So again, just double click and just type pump room 428. And you can do this for both points. The reason why you can do this is because it will display the function of that device, showing whether it is a water flow in alarm or the tamper in a supervisory condition. So this concludes naming your devices. The next column we're going to talk about is the supervisory column, which allows you to determine whether certain points will report as a supervisory signal to the fire alarm control panel and to the off-site monitoring facility. Tamper and supervisory conditions will automatically have this box checked, and this cannot be unchecked. Only smoke, heat, and CO detectors have the option to be checked to send supervisory signals. So again, just check mark the boxes of the devices that you choose to send a supervisory signal to the off-site monitoring facility. The next column, which is alarm verification, allows you to choose whether smoke detectors will utilize this feature. This is only for smoke detectors and allows those smoke detectors, while in an alarm state, to delay the activation of the notification appliances for up to 60 seconds. At the end of that time period, the smoke detectors are still in alarm condition. The panel will activate the notification appliances. If the smoke detectors are back to a normal condition at the end of the time period, then the panel will go back to a normal state. So again, just check mark the box of the smoke detectors that you choose to use alarm verification. The next column, which is low temp trouble, has to do with heat detectors only. This allows the user to select whether that heat detector will also serve as a low temperature trouble or supervisory condition, which can be adjusted to a specific temperature in the Zones tab. So again, if you want those heat detectors to initiate a low temp trouble or supervisory condition, just check mark the box for those specific heat detectors. EOL value is the next column, which allows the NAC circuits and I/O circuits on the control panel and the input circuits on the PSN 1000 power supply to have a custom end-of-line resistor value with a range of 2K to 27K. So again, if you need to adjust this, just double-click in that cell and change it to the desired value. The last column is the LED blink disabled, which allows the user to turn off the LEDs on a specific module or device. For instance, in a hotel application, the user could disable the LED on the smoke detectors located within the sleeping rooms. So if these were the smoke detectors located in the sleeping rooms, again, you can disable these by check marking those boxes. This concludes the points portion of the programming software. The next module is zones in the programming software. If you have any questions, please contact tech support at the number or email address shown on your screen.